Okay, this is MAT 175, Lesson 12, Section A, Point 3, 4.2, and 4.3, Properties of Rational Functions, the asymptotes and the intercepts, and then we're going to graph it. Analyze the graph of the rational function. Okay? Factor the numerator and the denominator to find the domain of the rational function. So basically, we don't have to factor the numerator. That's already x minus, that's already in simplified form. So the factors in the denominator, that's going to be x minus 2 and x plus 2. And so we set our denominators equal to 0, and we get x cannot be negative 2 and x cannot be a positive 2. And so that's where also our vertical asymptotes are at. Alright, so there's our domain, and right, R in lowest terms. Alright, so we've got that. Because there is no common factors between the numerator and denominator, what they mean is if we could cancel anything between the numerator and denominator. Okay, locate our intercepts. And to do that, we're going to set x equals 0, solve for y. Set y equals 0, solve for x. Alright, so let's see what that looks like. Okay, so what we're going to do here is set x equals 0, and we're going to solve for y. So that'll be r of 0 equals to put 0 in here for x minus 1 over 0 squared minus 4. And we get negative 1 over negative 4, and so we get a positive 1/4. And so, let me put this over here. So our y-intercept is at 0, 1/4. Now we're going to set y equal to 0, solve for x. So the process for finding the x and y-intercept is the same as what we were trying to find a parabola or a line or anything. So now we're going to put our y, our r of x, we're going to put that equal to 0. And then that'll be x minus 1. That almost looks like a 7. 1 over x squared minus 4. Now if we were to multiply the denominator out to both sides, well, 0 times anything, and these two cancel, right? Well, 0 times anything is still just 0. So this is still going to be just 0 equals to x minus 1. So technically, all you really have to do is just take the numerator, set it equal to 0, and we get x equals 1. So our x-intercept is at 1, 0. So we have our y-intercept, 0, 1/4. Our x-intercept is 1, 0. Okay. And so that's what they got here. They got 1/4. So that'd be 0, 1/4 for our y-intercept, and 1, 0 for our x-intercept. And now we want to know what behavior is the graph going to do near our x-intercept at 1. So what we do, we can't put 1 in the numerator, right, because that would give us 0. So we put in our 1's in the denominator. And so when we do that, we're going to get 1 plus 2 is 3, 1 minus 2 is negative 1, and so we end up with x minus 1. So what we get here is this would be the same thing as if we were to have said x minus 1 over 3 times a negative 1, right? So that would be like saying 1 times x minus 1 over negative 3. And so that's where the negative 1/3 comes in. So that makes it negative 1/3, and you don't need this 1 here. But because the fact that the negative 3 is in the denominator, that makes it 1/3. Okay, and so that's your equation. So it's going to be a negative slope going through that point. It's going to, the graph is going to be sloping negative as it passes through the x-axis at 1, 0. Okay, that's what that means there. All right. Okay, locate the vertical asymptotes. Well, the vertical asymptotes, we're going to set them equal to 0, right? We're going to set the denominator equal to 0. The denominator. And solve. Okay, so this would be x squared minus 4 equals 0. And whether you use factoring and the square root method, right, the result is the same. And then we apply square root, right, plus or minus. Don't want to forget that. We get x equals 2 plus or minus 2. So basically when we look on the graph, this is what we've got so far. We've got that we cannot have the graph go through, we cannot have a graph at negative 2, and we cannot have the graph at a positive 2, because we get undefined there. And we know that our intercept is at 1, 0, and if this is 1 here, then our y-intercept is at 1/4. So that might be a little bit high for 1/4, but that's okay. All right, and that's what we know so far. So now let's look at our horizontal asymptote. The horizontal asymptote we look at our leading terms. So we have here x over x squared. So now we want to know, is it less than, degree of the numerator, is it less than? If it is, then it's y equals 0. If they're equal to, then we take the coefficients so that would be a over b. And then if it's greater than, then we have no horizontal asymptote. Well, the degree of the numerator is less than, right? So therefore our horizontal asymptote would be y equals 0. And so it would be right on that x-axis at y equals 0. So you can go through a horizontal asymptote, but you can never go through a vertical asymptote because that's undefined there. All right, so let's see what our PowerPoint notes show. So there's our vertical asymptotes at negative 2 and positive 2 from setting that equals 0 and solving. Okay, we want our horizontal asymptote. So we found that it was at y equals 0 right here. And so it's going through. See, here's the line right here. Here's our dashed line. Can't see it because of the x-axis, but we do see it over here. That's y equals 0. And here's our x-intercept, and here's our y-intercept. And here's that behavior of the line, that negative 1/3, parentheses x minus, whatever it was, 1, I think. Yeah, x minus 1. So here's the negative 1/3, parentheses x minus 1, behavior of the x-intercept. Okay, and now, because the curve is going to come through here like this, it's going to continue on down here. And then it goes through the x-intercept, and it's going to go through the y-intercept, and then it's going to go up from there. And so what we don't know is what's going to happen on the outside of our asymptotes here and here. We don't know that yet, but we're going to find out. Okay, so what we do is we want to plug in some points and see what our graph's going to do. Well, they do like a table of values and that. But we're going to see it. What we're going to do is we're going to go ahead and we're going to take this x minus 1 over x squared minus 4, and we're going to plug it into the calculator. All right. So here we go to y equals, and we're going to put in here parentheses, and you got to use parentheses here, x minus 1 close parentheses divided by, and then open parentheses, x squared minus 4 close parentheses. And we're going to use zoom standard 6. And okay, that's what our graph looks like, but we need more than just this. We want to know what exactly is it doing, because it looks like it just kind of rides along there, but we don't, it could be actually be below it. We don't know for sure. So we go to second in table, and we want to know what is the graph doing to the right. In other words, past 2. So here's our table, here's 2. And notice there's an error there. Well, that's where our vertical asymptote is. Of course there's going to be an error there, because if we put 2 in here, we get undefined, right? So that's going to be an error. So we want to know, what is it going to do at 3? Well, at x is 3, we get a positive 0.4. Well, at 3, here it is, a positive number. And so if we go on to 4, we got a positive number, that's 0.25. And we go on to 5 and 6 and 7, they're all positive, but notice they're getting smaller and smaller and smaller and smaller. So what happens here, what it's doing is it's coming down here and it's getting closer and closer and closer and closer and closer. It's getting smaller and smaller and smaller and smaller. It's getting closer and closer to the horizontal asymptote, but it's not going to get to it. Okay, so that's what the x values show there, and so that's going to go on in that way and that way. Well, you don't have to draw all that. You can just go like to here. Okay, so let's see. Now, we know that our graph is going to come down this way because we have this point here tells us that. And the y-intercept here, that tells us that our values are going to be positive. So those are going to go up. But we don't know what's going on over here yet. That's a big question mark. So we go to our graph, and we go to our graph, and we look at what is the graph doing at number values less than a negative 2. Well, there's negative 2, there's our asymptote, and notice, negative 3 is a negative value, so it's going to be below the y-axis. And see, these are all negative, 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 negative. So that tells us that our asymptote, our curve, is below the y-axis, because this is our horizontal asymptote here. And our curve comes down like this. I missed the point. Comes across. There's our point, and it goes up. And that almost looks like a right angle. But anyways, there. That's better. And this one gets closer and closer and closer, but never does get to the horizontal asymptote. And so our graph comes up like this, goes through the y-intercept, goes through the x-intercept, and then down, because this point is negative. Okay, and this point, well, that's positive, so it's going to be above the horizontal asymptote. Okay, so really the only time you're going to get a line that's going to cross through most of the times through a horizontal asymptote is when you have an x-intercept, especially right when y equals 0. Okay. Oh, that's right. Alright, so we analyze the behavior of the graph as it reaches the asymptotes, and we determined that here we know that our point is positive, so it's going to come up. Here we have an intercept, and then here we have one point there's our graph. Okay. Analyze the graph of the rational function. Okay, so let's take a look at this. Here's our, we're going to draw a XY coordinate plane here. And so we'll start with our intercepts. So you're going to look for intercepts and you're going to look for asymptotes. Intercepts, set x equals 0, solve for y. Alright, so this would be r of 0 equals to 0 squared minus 1 over 0. Well, is there a y-intercept? No y-intercept. There's no y-intercept because we have a vertical asymptote. Well, we kind of gave it away because we end up with 0 and the denominator is undefined, right? So there's no y-intercept. Alright, so now we set y equal to 0, solve for x. Well, since we already know that if we multiply x over, that just goes away, so we just look at the numerator and set the numerator equal to 0 and solve. So we apply plus 1, and so we have x squared equals to 1, and then apply square root, plus or minus, and we get x equals to plus or minus 1. And so our vertical asymptotes are going to be at negative 1 and a positive 1. Or, no, that's wrong. Okay. So we know that these are our x-intercepts are going to be at, so we're going to see that our x-intercepts are at negative 1 and a positive 1. So we have two x-intercepts. Alright, so those are our intercepts. And now our asymptotes. Okay, let's start with the vertical. Okay, how do we find the vertical asymptote? Set our denominator equal to 0 and solve, right? So this is x equals 0. So we have a vertical asymptote right at x, right on our y-axis. So when they ask for the equation of the asymptotes are always an equation, either x equals or y. So you have to put that x equals, or you have to put the y, x equals for the vertical asymptote, y equals for the horizontal asymptote. Okay, so that's the vertical asymptote. The horizontal asymptote we're looking at the degree of the numerator, which is x squared over the degree of the denominator, and we find that there is no horizontal asymptote, right? So that means it must be an oblique asymptote. So we take our divisor, x, divide it into x squared, and then if you want to put a plus 0x, need a place for the x's, minus 1, we see that we're going to multiply x times x and get the x squared. And that's it. And so we subtract that, we get 0 there, right? And so there's no x's, so it's just negative 1. So our oblique asymptote is just y equals to, our oblique asymptote is just our quotient. Y equals to x minus 1 over divisor x. Well, we normally just drop the remainder, and it's just y equals to x. So that would make our oblique asymptote y equals to x. Okay, that's our line. Just like any y equals to x equation graphed out. Alright, so at this point, we want to look at, all right, what's going to happen now? So here we have our domain is at x cannot be 0. Behavior is, we set -1, we get 2, and +1, we get also 2. So they're sloping, both intercepts are sloping in the same direction. There they are. So basically, for one intercept, we put one intercept in here, the -1, right? This was x equals -1, that was that x-intercept. So we put -1 in all the x's except for where it originated from, just like before. And we get 2, so this would be -1 and -1 is -2 over -1, so -2 over -1 is a +2. And then we do the other one, 1. And that since that originated from x minus 1, we cannot put that in here. So that we would put 1 and 1 in the others, and we get 2 over 1, and we get 2 parentheses x minus 1. So here's our 2 parentheses x minus 1. We see that that behavior is sloping up at those 2 points. And we have our vertical asymptote, our oblique asymptote. And we have our vertical asymptote. So this is what we have now. And so we've already, we went through this part here. We did that already. And we got y equals to x. That's our oblique asymptote. And so we see that the line comes up, goes through 1, and comes up, and then it cannot cross the vertical asymptote, so it's going to come down. And then same thing the other way. Okay, analyzing the graph of the rational function. All right, now here we factor the numerator, factor out the common factor. We get an x minus 1 here, x plus 4, x minus 3. Nothing cancels. So we know that we're not going to get a whole. So we see that our vertical asymptotes, denominators equal to 0. Well, in this case, what they did is they found the y-intercept, put 0 in here, and we can see that 0 times anything is 0, so that's going to be 0. So our y-intercept is at 0, and so we want to know what is the behavior near 0, and it's going to be a line, like a line at 1/4 x. Well, we're also going to have, if we set our numerator 3x times x minus 1, set that equal to 0, we're going to get 0 and 1. So this is what we have so far. To find the intercepts, we're going to set x equals 0, solve for y. Okay, so this will be r at 0, and we put 3 times 0 in here. 0 minus 1 over 0 plus 4, 0 minus 3, and we get 0 over -1, right? Over 4 times -3. Well, that's just 0. So our y-intercept is 0, 0. Our x, so if we set y equals 0, solve for x, we take the numerator, set it equal to 0. 3x, parentheses, x minus 1, and so we set each factor equal to 0. divide by 3, right? Divide by 3 here, we get x equals 0, x equals 1. So that would be 0, 0, and 1, 0 for our x and our y. So that's our x. These are our x-intercepts. This is our y-intercept. All right, and so now let's say we want to find our asymptotes. Asymptotes. All right, we take a look at we'll find our y asymptote. Look at our degree of the numerator, 3x squared, leading term, over the degree of the denominator, 1x squared. Since our powers, or our exponents, our leading exponents, are the same, then that tells you that our asymptote is y equals what? Right, 3 over 1, right? Or just y equals 2, 3. Here's 3, here's 1, so it's 3 over 1. So we're just going to say y equals 3. Okay, now for our vertical asymptotes. Our vertical asymptotes, what do we do? How do we find that? Take our denominator, set it equal to 0. X squared plus 1x minus 12, factor it. We get x plus x minus, right, 4 and 3. So we get x equals to a negative 4 and x equals to a positive 3. Okay, so this is what we've got so far. We've got we have an intercept, our y-intercept, and our x-intercept is at 0, 0. We have one more x-intercept at 1, 0. Okay, so those are our intercepts, our asymptotes. We have one y-asymptote at y equals 3. And we have two vertical asymptotes at x equals to a negative 4 and x equals to a positive 3. Okay, and so this is what our graph looks like so far. Alright, so let's see, from there we can go ahead and go to our calculator and see, okay, what is our graph going to do? Is it from 0? We know it's going to come through here, right? Come through here and come through here, but we don't know if it's coming, up and then down, or so we're going to take a look at our behaviors from there. So we saw that there was nothing that canceled, so we have our x-intercepts at 0 and 1, and we also know that our y-intercept is at 0, 0, and we know that our behavior at 0 is 1/4. So it's going to be, what that means is it's going up, but it's very shallow slope. So chances are what it's doing is coming up and then going back down this way, like that. Okay, and so that's the in between the asymptotes, but we don't know what is it doing out to the left of the asymptote, and we don't know what it's doing to the right of the asymptote. We don't know what that's doing yet. So you're always going to have curves on both sides of the vertical asymptotes. So from there, we can go ahead and go to we look at our values. What are they doing? Are they going, are they positive, are they negative, are they getting close to 3, or what are they doing? And so at 1, we have a negative slope, and that's what this is. It's a negative slope. So we know it's coming up. Here's the 1/4 x. Here's the negative 1/3 x. So we know it's coming up and then back down again. All right. And so as our graph, so here we've gotten this part so far, and we know that it comes down this way and down this way. But we don't. So if we go to our calculator at -4, we plot in like -5. What is it doing there? So if we, let's see, negative, we would have to go ahead and put in here 3x squared open parentheses, and you could either put it in, you don't have to put it in factored out, you can put it in the original format. 3x squared minus 3x, close it, divided by open parentheses x squared plus x minus 12. Close it up, and we're going to go to zoom standard again. Okay, so if we go to second in table, something, here's -4, that's where our asymptote is. -5, it's positive. So it's above, so this is above 3, which is our horizontal asymptote. And then 4, 5, and if we go more negative, more negative, more negative, we can see that it's always above 3. So that means our graph, our curve on this side is going to stay above 3. It's not going to cross that horizontal asymptote. All right, so let's see what else it's going to do. What happens to the right side of 3? So we go back to our calculator, and let's take a look. Here's, keep going. Okay, here's our other vertical asymptote. Well, let's see what that's doing. That's positive. 4, 5, that's above 3. 5, 3.33, that's above 3. So you can see, oh, it crossed. It crossed the horizontal asymptote right here between 6 and 7. And now it's riding below the horizontal asymptote. So this is what it's doing. We know that our graph, is coming across like this, and that one stays above 3 the whole time. I'm going to use black instead. We know that one stays above 3 the whole time. But here between 6 and 7, it crosses, and then it rides along just below it. It rides along it, but it's below the horizontal asymptote. And here our curve comes down. We know that it comes down this way and the other way. Okay, and that's our rational function. And that's what it looks like. Okay, now here, if we were to factor out the numerator, you can see that these two cross. We can cancel them out. And so we have just one x-intercept that if we set the 2x minus 1 equal to 0, set the numerator equal to 0, we get 1/2. So that's that's going to be 1/2, 0. Now for the y-intercept, set x is equal to 0, we get a negative 1/2. So that'd be 0, negative 1/2. The x-intercept is 1/2, 0. And our vertical asymptote, that's just at x equals to negative 2. And we see that our horizontal asymptote, that's going to be at y equals to a positive 2. But what happens here is because these two cancel out, we still can't have a positive 2 because that's still going to give us an undefined, but that's going to be a hole. And so that's what this is here. So here's our vertical asymptote at x equals to a negative 2, but we don't have another vertical asymptote. That's just a hole there. Now your calculator is not going to show that, but if you go to the table of values, it'll show that it's an error there, or an undefined. And so our y-intercept, that was at negative 1/2, 0, negative 1/2. X-intercept was at 1/2, 0. So here's that where it comes up, hole there, continues on, and this goes down. And then our other value is above the horizontal asymptote. So we have one vertical asymptote, one horizontal asymptote, and that's our graph. And that concludes our lesson.